Hi, everyone. Today is day 24, I think. Probably should have checked that, but whatever. So today's Saturday, February 8th, 1:17 p.m. I have exciting news to share with everyone. My keyboard is repaired. For months, every time I press G or down arrow or right arrow, it would pop out of my keyboard and slide around. So I've never been more excited to code than now, frankly. Um, so off camera when I wasn't recording the videos, I um, revised my subsets 2 solution, which I talked about last episode I was going to do. So the trick is you like sort it first. I'm not going to talk too much about that. I also did letter combination of a phone number just now before recording, which this one was pretty good. Felt good. Um, yeah, so today I'm thinking I'll do the last um, backtracking problem. I did this one a long time ago. Yeah, it was September 23rd. So to be honest, I'll just redo it. Like, I don't really remember it at all. So I'll do word search, and then maybe next episode I'll do palindrome partitioning. But yeah, so let's get started. Okay, so I looked at this one a little bit, but I'm pretty sure it's just a word search. So given a 2D grid of a character's board and a string word, return true if it's present, otherwise false. For the word to be present, it must be possible to form it with a path horizontally or vertical. The same cell may not be used more than once in a word. Oh, okay. It's not a traditional word search, so you can like move as you're searching it, and you can't. Okay. Um. Yeah. So I think the idea is, and we're only given one word, huh? Okay. Yeah. So let's call a function called search. Um. So we want to search from probably every position, or should we just start at the top left and it'll work? Okay. Yeah. So let's think about how I want to do this. Um. So obviously, if we knew where the C was, so if we look at this example, B, C, D, A, A, T. So wherever you currently are, you're going to search all adjacent directions. So you would say if it equals, so you're at I, right? And then if it equals word of I plus 1, so if it equals this character, then search that character. Um, so I'm wondering if it would be easier to just like do this iteratively. This reminds me kind of the advent of code problems. Um, yeah, because I mean, what I could do, well, I think maybe you just search every position. Okay, so if we can generalize this, so so you would call search on every position, and then like if, um, so what do we need to know at every substep? We need to know I, like what index of the word we're currently on. I think that's it. well, what else? We need the letter maybe? Or we need the position. Okay, so position, we'll say row column equals position. So we could start yeah, so this is kind of a general way of doing it, I guess. I could say for r in length of board, so that's the number of rows that it has. And then for c in length board of 0, so this is how many columns every row has. We can search I guess we could do this. So row, column. So we'll take in the row, the column, and I. So that's like the of word. So that's the target. So for instance, we have cat. 0, 1, 2. So we're looking for word of 0. So if board of row column does not equal word of I, then you get out. So in this case, this will filter out every C so far, or every non-C. So let me just verify this is working. At position, row, column. Okay, and for now we'll just return false. Range. Forgot the range function. Also, I don't need this else here. All right, so found a C at row 0, column 2, and row 2, column 1. Okay, so that seems to be working. So if we find what we're looking for, then we want to search all 4. But the problem is we don't want to go where we've already came from as well. So the same cell. So for instance, if we had a word BAB, we wouldn't want to be able to go BAB. So I wonder if we need, yeah, and if we had a word like, let's say this was our grid, right? And we had a word CDBA, that's valid, but if it ends with C again, that is not valid because we used this C twice. So I'm wondering if we need to I guess what we could do is just have a list or a set of visited a set called visited, which is a set of rows and columns that we visited. So we could say and we can say if RC in visited, then we can return as well. Okay, and for visited, we'll pass empty set. Okay, so if it's not the word we're looking for, or if we've already been there, we can return. Otherwise, we want to search all 4 directions. So for RC in, I guess, okay, Okay, so all 4 directions would be like this. So to the left would be -1 row. No. -1 column. Up would be -1 row. Right would be +1 column. And down would be +1. Sorry, I think I messed this up. Right would be +1 column. So row, column. And then down would be +1 row like this. Okay. So these are all the directions. And then I think we want to call search. I think we also want to say, so we probably want to add visited here. Okay, so search, so row, I'll just put them in variables so it's easier. Okay, so new row is going to be equal to row plus delta R. New column is going to be column plus delta column. So it's going to be new row, new column, I +1 because we're looking for the next word, and then visited we'll add here like this, visited. Okay. Okay. Also, our base case, like if we find the word, should be if I equals length of word, then found word ending at RC. Okay, so if we found the word, right, because if I is equal to the length of the word, that means that we found it. Okay. And every time we call search from the beginning, it'll clear visited. Sets, I'm wondering if we have to, if I have to pass a copy of visited. Oh yeah, and I also have to check if it's bounded. Okay, so I think we can actually. All right, so return if if it's greater than or equal to R and less than, or sorry, 0, and if it's less than, so for the rows, it has to be less than the length of boards. And columns less than length of boards of 0, like that. So I think we can turn this into a lambda function. So if it's not bounded, or we could say like that, doesn't really matter. I think it's better like this. Okay, if it's not bounded, and let me see if that gives me the same error. So where is that? Line 20. That should fix the bounding error. Can I pass a tuple? Oh, that's... Oh no. Am I doing it wrong? Alright, whatever. For another day. I'll just keep it down here. So if not bounded, so that should fix that problem. Alright, I have to think of the order of how to do this. So if it's not bounded, that seems like a good place to start. If we visited it already, that seems fine. And then I guess we can try this one here like that. Okay. Had 0, 3. So row 0, column 3. Word ending at... I don't think this is where it ended. So we found it twice. C-A-T... C... Let's see. So it looks like it's finding it. I don't know why it's finding it twice, though. Okay, so found word of I at let's try printing that. Okay, so found a C, found an A, found a T. So we should just put it here. Okay, found a C, found A. Perfect. So I think it's working. It's just this part right here. It might actually just be working. Just like this. Okay, so here we want to return true. The only reason I can't put this one first is because this checks if we've already found it. Because if it's looking for okay, I'm pretty sure it's working. So let's just and then what's the runtime? Yeah, that makes sense. All right, now I'm thinking the best way to do this is probably just say found equals false. So right now I'm just wondering if there's a way to do it without using like a global flag. Because you could have each search return either false or true, and then take the union. But I'm wondering how you would take the union. So if you have each search return false or true, you want to check if any of them return true. We could say is if this, then return true. So if any search returns true, then return true. And if you get to the end, then return false. We can't just say, or can we? Can we just say return this search? Okay, so if it's not bounded, that search is false. No, we can't just say this because then it'll just do 0, 0. If you had it like if it was false, it would move on to the next position, then it would probably work. Return true and return false here. Okay, let's try that. So this function will return this function. So are we never in here now? Let me get rid of all the print statements for a second. We're almost there. Okay, so it's just returning false. I think it could have something to do with this. Let me see the order that it's getting called. So 0, 0, 0, 0, 1, 0. So, okay, so row column. Row equals. All right. 0, 0, 0, 0, 1, 0. Okay, so it'll keep going until it finds the C. Okay, so now, okay, so we found the C. Now it's looking for 0, 1. So it's checking there. That's not it. So now it's gonna. Why did it only do it once? Okay, so when this returned false. Okay. So this whole for loop doesn't execute. Okay, so we could just say found equals false. If any of these are true, then found equals true, and then return found. Like that. Wrong answer. Should we? This isn't gonna fix it, but Okay, so the board has 1 row and 1 column. So let me use that as a test case. I think this is fine. So basically it'll say that it hasn't found it, and if any one of the 4 calls return true, it will find it and return either false or true to its parent that called it. 30 minutes. Okay, we're not doing too bad. So with this, right, so what's going to happen, it's going to search 0, 0 at I equals 0. And then it is bounded because they both equal 0. And it's not invisited, so this will get skipped. I is 0, which does not equal the length of the word yet. So it'll equal. So this will get skipped. Board of RC does equal here. So right here, when we're here, yeah, then we know that we found the word, or we found a letter. We found a correct letter. So I almost wish, like, right here we could just check if we won. So if I equals length of word, well, I hasn't been incremented yet. Can we increment I here? Because we do it down here, but we don't have to wait until here because we don't use it. So I wonder if we can check. So if we say I equals here like that. Yeah, my only problem with this is that word of I will sometimes be out of bounds here. So it feels weird to me to have this condition twice. But if I get rid of this, I'll get an error, I think. Or does it just check it right here? Oh, okay. So I can never be out of bounds, because if it is, we'll get it right here, and then it can never be called out of bounds. Okay. There might be a better way to do this where you just start at 0, 0, and then if it's, instead of doing this nested for loop, you can start at 0, 0, and if it's not the letter you're looking for, then you can start a new search from that letter. So like here, you would start a new search from that letter. So if it doesn't equal the letter, you would call it again with like a reset. So you'd reset I to 0. And for visited, though, I think visited would have to change, because you don't want to just go back and forth between A and B forever. So it gets a little tricky, because if you have, for instance, A, B, like, let's say you have A, B, A, T, and you have A, C, D. So let's say that you do it the way I'm suggesting. So you'll search A is not a C, so then let's say you go to these two, and then you see B is not a C, so then you go to so these are both in visited, so you pretty much mark them off, and then you go to A, and A is in visited. So by the time you get to the C and you go to this A, it would already be in visited. unless you have two visited sets, which would be like start points and then like a local visited. But I think that sounds pretty complicated. And I wonder if just doing it this way is better. Anyway, yeah, so that's today's episode. I have wrong answer now. What? Oh, yeah, my bad. All right, so that's today's episode. So it was 35, 36 minutes. Not bad. This one, what was challenging about this one? Honestly, it wasn't really that challenging. I don't know. I think for me, the hardest part was just the returning. The return, I basically was kind of stubborn and I didn't want to use like a global variable and have every, because what you could do is just have every call say like if found return, and you could just have like found equals true and say, sorry, found equals false. And then whenever you find it, you would say found equals true. And then at the end, you would just return found. But I didn't want to use a global variable for some reason. Maybe it would have been better that way. I don't know. Let's see if the solution does that. Okay, so they did it the way I did here. Well, actually, that's only one solution. Same thing. Same thing. Okay. Yeah, so it looks like it was a similar approach with just doing it for every grid. All right, well, thank you everyone for watching. Tomorrow I think I'll do this problem because I don't think the way I did it was good. And maybe I can revisit it and try again. So yeah, thanks for watching everybody. That was day 24, I believe.